In this video, we will be solving this question which says, on your graph, sketch the indifference curve that passes through the point 30,000, 40,000. If plan B is adopted, at this point, which is steeper, the indifference curve or the budget line? So in the previous question, we were given different plans, out of which plan B was that this plan would give 10,000 grant to any high school as long as the school spends at least 10,000 more than it currently spends on computers. Any high school can choose not to participate, in which case it does not receive the grant, but it does not have to increase its expenditure on the computers. So this was the graph we had, where and on the x-axis we have thousands of dollars worth of computers, and on the y-axis we have thousands of dollars worth of other things. And this red line corresponds to the budget line for this plan. The question says that we have to first sketch the indifference curve that passes through the point 30,000, 40,000. We were given that the utility function took the form of c, x is equal to cx square. If we have to draw the indifference curve passing through the point 30,000, 40,000, all we have to do is first calculate the utility at this point. So that would be utility at 30,000, 40,000, and this would be, so now we have to substitute c with 30,000 and x with 40,000. That would be 30,000 multiplied by 40,000 square. So this would be 48. Now we have to draw the indifference corresponding to this value. That means we have to find all the combinations of computers and your other things such that their combination gives this value of the satisfaction. So your indifference curve would have the equation as cx squared is equal to 48, these many zeros. So if you try and draw this curve, this would look like this. So this black curve is your indifference curve that passes through the point 30,000, 40,000 if plan B is adopted. Now the question further says, which is steeper, the indifference curve or the budget line? So whenever we are talking about what is steeper or flatter, so basically we are trying to compare the slopes of the two things. Now here, the slope of the indifference curve is nothing but the MRS, and the slope of the budget line is nothing but your price ratio. So your MRS we calculated in the previous part, which was equal to minus x divided by 2c. So the slope of the indifference curve, which is MRS, which is minus x by 2c divided by for this particular case. So MRS at 30,000, 40,000 is nothing but minus of 30,000, as x is taking the value of 30,000 and multiplied by 2, divided by 2, multiplied by c is taking the value of 40,000. So that would be, this is nothing but minus 3 divided by 8 or minus 0.375. The slope of budget line is your price ratio. So for this particular case, the price ratio of this budget line was 1. If you're not able to relate to this value, then you can refer to the previous question where I solved for the equations of the budget line, and from there you can always calculate your price ratio. This is your minus 1. All we have to do is just compare this value and this value. That is the slope of the two curves. Clearly, minus 1 is greater than minus 0.375. So, higher the slope, steeper the curve. That implies the slope of budget line is greater than the slope of indifference curve. Here I see presents your indifference curve. So clearly, as minus 1 is greater than minus 0.375, so your slope of budget line is a lot greater than the slope of your indifference curve. So your budget line is steeper. Now, if you do not want to do this math and you have clearly drawn your graph, what you can do is you can also try and see this graphically. How would we do that? So at this point, we would be drawing a tangent. This blue line is your tangent at the point 30,000, 40,000. This is not a precise tangent, but you can still get an idea. So clearly here also your red line is steeper as compared to blue line. So your budget line is steeper. So there were two methods for this question, and you can choose any of your choice. Either you can go for a graphical approach where you're comparing, where you have to see how is the tangent steeper than the budget line or not, or you can go for a mathematical method where you're comparing the slopes of the two graphs, and the slope of MRS and the slope of indifference curve is MRS, and the slope of budget line is your price ratio. Now let's move on to the next part, which says if plan B is adopted, find the expenditure on computers that maximizes the district's utility subject to its budget constraint. And we are given a hint that look at your graph. This was the plan B, where government intends to give 10,000 grant to any high school so long as the school spends at least 10,000 more than it's currently spending on the computers. And if any school does not participate, then that school won't be getting a grant, but it doesn't have to increase its expenditure on computers. This was the graph we drew in the previous part. On the x-axis, we have thousands of dollars of computers, and on the y-axis, we have thousands of dollars worth of other things. So your red line is nothing but your budget line, and your red and your black curve is your indifference curve. Now clearly that this is the highest curve that is touching the budget line. So this indifference curve ensures the maximum utility that the school would be getting. And this indifference curve is touching the budget line at the point 30,000, 40,000. So you have the point as 30,000, 40,000. Since you have computers on the x-axis and other things on the y-axis, your consumption bundle would be of the form C, X. If we compare this consumption bundle and this consumption bundle, your C gets the value of 30,000. So if plan B is adopted, the expenditure on computer that maximizes the district utility subject to its budget constraint is 30,000. Since this is the highest indifference curve that is touching your budget line.